65%. That's the share of agent-written Python pull requests where no existing test ran a single line they changed. So what are we really checking? This is the Agentic Daily Brief. Anthropic has reportedly written a $10 billion check to a company that didn't exist a year ago. 6 years of compute from a startup called Volta, which is putting up a data center in Norway with a crypto mining partner, 133 megawatts of it, built around NVIDIA's Vera Rubin chip design. The money isn't the interesting part. It's who got it. Frontier Labs have stopped waiting for the big clouds to build, and they're funding brand new suppliers to do it instead. One more before we dig in. The safety group Safer AI tested an open weight model from the lab ZAI, weights anyone can download, and found it trailing the frontier by only a few months on cyber and biology work, while refusing nothing at all that it was asked. Okay, picture the pull request sitting in your review queue right now. An agent wrote it. The build is green. You've got about 4 minutes before your next meeting. How much does that green actually tell you? A study out in late July, written up for a software maintenance conference, went through thousands of pull requests written by coding agents. It asked one narrow question. Of the lines those agents changed, or rather the ones that actually run, how many does any existing test touch? In Java, about 6 in 10. In Python, under 3 in 10. The error handling was worse still. Those are the paths that only fire when something's already going sideways, and across both languages they were the least covered code in the whole dataset. Here's why that's not just an academic number. Suite-level coverage is an average over code nobody edited today. It can sit high and tell you nothing about this diff, because the lines in this diff are brand new. The question that matters is narrower and harder. Did anything run what just changed? That's showing up in the mood too. DX, a research shop that measures developer experience across hundreds of organizations, reported that code maintainability ticked up while confidence in shipping changes went down. Median pull request size nearly doubled in the same window. Bigger diffs, less faith in them. Honeycomb's Fred Hebert put it flatly. New code could be generated much faster than we could assimilate. A passing build on an agent's pull request tells you nothing about the lines no test executed. The more important question isn't whether agents write buggy code, it's whether anyone can tell. Because, the biggest dataset in that same stretch cuts the other way. More than 200,000 closed pull requests across popular Python projects, and the agent-written ones were no more defect-prone than the human ones. Not worse, comparable. So both things are true at once. The code might be perfectly fine. What's thinning out is our ability to know that it is. Hebert's team, by the way, didn't fix that by generating less. They leaned into the review bottleneck and kept their speed anyway. Which brings me to what all that verifying costs. 2 teams run the same model. Same effort setting, same quality of result at the end. One team's bill is more than twice the other's. How does that happen? Databricks ran exactly that test in July. 1 model, 1 thinking effort, 2 different harnesses. The code wrapped around a model that feeds it context and runs its tools. They pointed both at their own multi-million line codebase. The work came out equally good. Cost per task differed by more than 2 times. The cheaper setup simply shipped less context into every single turn. Meanwhile, Anthropic shipped Claude Opus 5 in late July at the exact same per token price as the model before it. Unchanged sticker. Then Artificial Analysis, a benchmarking shop, ran that one model against itself and watched the cost of a finished task climb by more than half, just from turning the effort dial up. Part of that is quiet. Thinking tokens bill at output rates even when you never see the thinking. So a model that reasons longer costs more without a single line of your code changing. And if that holds across your workload, the price you negotiated barely predicts the invoice you get, right? My read is that per token pricing is the number you shake hands on and roughly never the number you pay. You pay for turns, retries, and reasoning, and those are decided by what you built around the model on every run. Both measurements carry a footnote though. Databricks measured on Databricks code, not yours. The Opus figures are launch week, one from the vendor, one from a benchmark house running its own task set. The practical version is small. Price agent work in dollars per accepted task and remeasure it every time you change something. The model, the dial, the wrapper around it. One last story before you go. You've had this happen. An agent is deep into a long job and something restarts. A deploy goes out, a client crashes, somebody walks away from a prompt and doesn't come back. The whole run is just gone. That's not really a failure of the agent. It's a question of where the work was living. It was living in the connection. On the 28th of July, the Model Context Protocol project, the open standard agents used to talk to their tools, published a new spec and deleted the session outright. No opening handshake, no session identifier in the header. Every request now carries its own version, identity, and capabilities right there in the message. Which means any request can land on any server instance, behind a plain round-robin load balancer, with nothing shared between them. The long-running work piece moved out into a separate extension, contributed by Amazon. And when a server genuinely does need to remember something, the answer is blunt. Hand back a ticket and make the model carry that ticket into the next call. State travels in the message, not the pipe. So where's the hole? This is a spec, not shipped software. The clients and toolkits still have to implement it. Polling for an answer costs you extra requests where you used to hold one pipe open. And a ticket the model carries is input the model controls, so you scope it and check it on every single use. Still, the design lesson lands whether or not you ever touch that protocol. Anything your agent holds open across turns is a bet that nothing restarts. That bet loses on an ordinary Tuesday afternoon deploy. Before you go, one thing worth trying tomorrow. Take the last pull request an agent opened for you. Check one number. How many of the lines it changed does any existing test actually execute? Not the sweet percentage on the dashboard. Those lines. It takes about 5 minutes and it usually stings a little. And one talk worth your time this week. Kate Atkinson from Ping Identity sat down with Google Cloud's Sid Siraj to talk about authorizing agents while they're running. Her argument stuck with me. Knowing who an agent is isn't enough anymore, because the relationship isn't two-way. It's a person, an agent, and the resource in between. And application code can't be the thing that decides. So, back to that green check mark. The build that passed, the price on the sheet, the connection that stayed open. Every one of those measures the setup. None of them measure what came out the other end. That number is the one you have to go looking for. That's today's Agentic Daily Brief. Brought to you by Agent Native Engineering, open knowledge for building and running AI agents. The full write-ups with their sources are at agentnativeengineering.com. See you next time.